Okay, is the following series convergent or divergent? Justify your answer. So notice that here we're not really asked about whether the convergence is conditional or absolute, because all the terms in the series, they have that they're positive, right? So with large values of n, cosine n is between -1 and 1, so n cube is much, much bigger. So the denominator is positive, the logarithm n is still positive, so it's just positive. So for series whose terms are positive, convergence is the same as absolute convergence. Well, in any way, so how do we approach this? Basically, the intuition behind it is that ln n, as n goes to infinity, it grows slower than any power of n, right? So it grows slower than square root of n, it grows slower than n raised to the power 1/10, it grows slower than n raised to the power 1 over 1 million, and so on, right? So at the same time, in the denominator, we have cosine n, which just you can think of it as just a constant because it's just bounded between -1 and 1, right? And we have the really big term n cube, right? So overall, it is something like a rational function where the numerator is basically its degree is smaller than any positive number, and the denominator has degree 3. So the ratio is still, 3 minus any positive number is still bigger than 1, right? So it is like a p series where p is essentially any positive number that is less than 3, but it is still bigger than 1, so the series converges. That's for sure. So how can we prove it rigorously? Well, basically there are different ways to do it. I think the easiest way is to just estimate logarithm with n from above, right? So let me write it. N is, sorry. So very simple inequality. Ln n is less than n, right? And cosine n is bigger than um, -1, right? So ln, applying these two inequalities, we see that ln n divided by n cubed plus cosine n is less than n divided by n cubed minus 1. So which means that if we can prove that the series, the sum from say 2 to infinity, n over n cubed minus 1 converges, then so does the original one. Then so does the original one. So how do we know that this series converges? Because we can compare it with the p series, right? So we can use the comparison limit test by comparing it to the p series where p is 2, right? So n divided by n cubed minus 1 divided by 1 over n squared is basically n cubed over n cubed minus 1, which is, now we can divide by n cubed, is 1 over 1 minus 1 over n cubed, which is, the limit is 1, so the ratio has a non-zero limit, and we know that the series from 1 to infinity, well, it doesn't matter, from 1 or from 2, and square converges. So since the series converges, so does this series, and therefore the original one, so the original one is the series of these terms also converges.